Here the ninth problem, for the trapezoidal pulse, that is x of t, shown in figure, find the total energy. They only telling here, they are given a trapezoidal pulse. This is your trapezoidal pulse, where it is varying from -5 to +5 with the amplitude as 1. Here a pulse is given for us. What we have to calculate? We have to calculate the energy. What we have to do? First, just you observe the pulse and then divide the whole pulse in terms of a lines. It will be easy. There are two methods I can go for, by using of the line equation or else by using of the areas. That is area of a triangle. If I take this part from -5 to -4, here a small triangle will come across, and from -4 to +4, here it's of a rectangle, and again here we have a triangle, that is from 4 to 5. You can use the area equation, half breadth into height for a triangle and for length into breadth for the rectangle. Like that you can use the area of the each part, or else this is one method, or else we are going to divide the whole pulse in terms of lines. Means from -5 to -5 to -4, this is one line, right? And then from -4 to +4, one more line is there. Then from 4 to 5, from 4 to 5, this is one more line. What I will be doing next, I will make the points for the two lines. This is one end of the line of this, and this will be the another end. What is the point? If I tell, how you tell the points here? First we will be writing of the x-axis, that is here it is of -5, comma, then y-axis at this point will be 0. This is one point I will be getting. Then at this point, other end of the line, what is the point here? I will be getting points. Here is of x-axis of -4, comma, then y-axis is of the amplitude is 1, right? For that reason, point is going to be at this end for the line. The point is going to be taken as -4, 1. It will be remain same for the whole until it will be same at 4 also. Here, what is the point I will be getting? 4, 1. And here I will be 5, 0. Here -5, 0. This is the end point of the line. That points what you have to take. Here -4, 1. Here 4, 1. And 5, 1. Points you will be getting like this. Next, what you have to do? We have to use the equation, line equation. This is your standard line equation, where you will be getting as y2 minus y1 divided by x2 minus x1. That is going to be equals to y minus y1 divided by x minus x1. This is a standard equation. Remember this. Okay. Next, what you have to do? For the line from -5 to -4, this is a straight line. We are considering of these 2 points here now. So here I taken as x2, y2 as this point, that is -4, 1 as x2, y2, and x1, y1 as -5, 0, -5, 0. You can take reverse way also, no totally problem. You will be getting the correct value only. But while solving, be careful. Okay, from -5 to -4, we got these points. Then that is our y of t is going to be taken as x of t, because that y-axis is going to be taken with respect to x of t, and time it is in a x-axis. For that reason, x is going to be taken as t. What you have to do? Just substitute all the parameters in the equation of a line equation. So what is our y2? Y2 is of 1. Substitute that 1 minus y1. What is y1 here? It will be 0. This is y1. This is our x1. And this is our y2. And this is our x2. Substitute here. x2 is of minus 4 plus minus of minus, because x1 is of minus 5, minus of minus plus 5. Then y is of x of t. Then y1 is 0. Y1 is 0. X is of t. X is of t plus 5. Minus of minus plus, for that reason plus 5 you will get. Solve for this. What you will be getting? Here 1. You will be getting as 1 by 1 is equals to x of t divided by t plus 5. What is our x of t is going to be taken here? X of t is going to be taken as t plus 5. If I cross multiply here, you will be getting as x of t is equals to t plus 5. In the same way, at 1 is minus 4 to 4. What is the here? X of t is, what is the x of t value here? By using of the line equation also you can go for, or else directly here it is given, that is the whole amplitude is of only 1. For that reason directly you can write here as x of t is going to be 1 only. Next, for 4 to 5. For t 4 to 5, again use the same equation. Substitute, take here x2 y2 as 4 comma 1 and x1 y1 as 5 comma 0. Same here 4 comma 1 and 5 comma 0. Next, use the formula. In the formula, that is y2 minus y1 divided by x2 minus x1, y minus y1 divided by x minus x1. Substitute here, you will be getting as 1 minus 0, 4 minus 5, y minus 0 divided by x minus 5. Then solve for this. Y is nothing but x of t, x is nothing but t, right? Here 1 you will be getting, here 4 minus 5 is minus 1. After substituting for y and x, here x of t divided by t minus 5. If I just cross multiply here, so x of t is going to be taken here, then multiply minus 1, cross multiplication if you do, what you will be getting? Here you will be getting as minus 1, you have to multiply for this. For that reason, minus t plus 5. X of t is 5 minus t, where t is for 4 to 5, it's of 5 minus t. 5, I can write minus t afterwards. 5 minus t, then minus 4 to plus 4, it will be 1. From minus 5 to minus 4, it will be t plus 5. And for other cases, it will be 0, because beyond minus 5 to plus 5, there is no signal for us, for that reason. Okay, we got only of x of t. What is our energy equation? It is of E is equals to integration minus infinity to plus infinity x of t whole square into dt. Then what you have to do? Just substitute for the range from minus 5 to plus 5. What is the, where our signal is existed, that limit you have to take. So minus 5 to plus 5 x of t whole square. Next what you have to do? We have to again bifurcate the integration, the limit minus 5 to plus 5, I can bifurcate, divide from minus 5 to minus 4, then minus 4 to 4, then 4 to 5. Okay, then what you have to do? Then I wrote here by expanding the limit minus 5 to minus 4, what we got? It's of 5 minus t. Sorry, here minus 4 to minus 4 is of t plus 5 whole square. Then minus 4 to 4 we got as 1. Substituting 1 into dt as it is. Then from 4 to 5 it's of 5 minus t. from 4 to 5, 5 minus t whole square into dt. Next, what you have to do? Use a plus b whole square. Don't go for direct substitution and all. Go with one by one step, then only you'll get the exact result. Okay. T square plus 5 square, a square plus b square plus 2ab. So you'll be getting as 10t dt. Here as it is. Then 5 minus t whole square, a minus b whole square, a square, t square plus 5 square minus 10t into dt. You will be getting of this equation. Then solve for each parameter. First you go for t square. So take the integration minus 5 to minus 4 t square into dt, multiplying for each parameter here dt for this also and also for the 10t. Then applying integration for each parameters. Minus 4 to 5, then 5 square means 25 into dt, then 10t integration minus 4 to minus 5, minus 5 to minus 4 into dt. Here it will be as it is. Then again here also the same. For each parameter you apply for the integration and also for the dt multiplication. So you will be getting as integration varying from 4 to 5 t square into dt, 25 into dt, then plus this minus 10t, I wrote here only 10t into dt. Next, what you have to do? Then you go for integration one by one. Integration of t square is t cube divided by 3. Apply limit minus 5 to plus 4. Then plus 25. Integration of 1 is nothing but t only. So minus 5 to minus 4 limit. Then 10t means 10t square divided by 2. So with the limit minus 5 to plus 4 minus 4. Then here only 1 is there. 1 if it is there means integration is going to be taken as t. With the limit is minus 4 to plus 4. Again t square is nothing but integration t square is t cube divided by 3 with the limit 4 to 5. Again here 25, only 1 will be left if I write 25 outside. So 1 dt is nothing but t. You will be getting limit is 4 to 5. Then this minus I wrote here 10 t integration is going to be taken as t square divided by 2 with the limit 4 to 5. Next, what you have to do? You have to apply the limit. First, upper limit is of minus 4 cube minus of minus lower limit, that is of minus 5 cube divided by 3. Then 25. Here what is the limit is of minus 4 minus of minus 5. Minus 4 minus of minus 5 you will be getting if I apply the limit. What is of minus 4? Minus of minus is going to be plus. Minus 4 plus 5 means 1 only you will be getting. So I wrote directly as 25 here. Then 10 upper limit is of minus 4 square minus of lower limit is of minus 5 square divided by 2. Then here also what will be getting? Upper limit is of 4 minus of the lower limit is also of a minus 4. What you will be getting here? 4 plus 4 you will be getting as 8. I wrote directly. Then for here t cube upper limit is of 5 cube minus lower limit is of 4 cube divided by 3. Then plus here 5 minus 4 you will get. Upper limit is 5. 5 minus 4 you will be getting as 1. 1 into 25 is 25 only. Then here minus 10. 5 square because upper limit is of 5 square minus 4 square divided by 2. If you solve for each parameter, then you will be getting the result as energy as 26 divided by 3 in terms of joule. Don't forget to write the joule. Okay, this is how you have to solve for the given graph or else a pulse, trapezoidal pulse for the energy. This is how we have to solve for this. This is very important and many times it is repeated in the examination. Don't keep in your mind that only like this figures will be given or else the graph will be given for us. They may give only a pulse from varying from minus 3 to plus 3 or else they may give the change like it is varying from minus 3 to 2 with the different pulses. Don't fix your mind that the pulse will be given like this. If it is given, it's well and good. But don't, just remember how to solve a problem by using my priority use of the line equation. It will be easy for us. Okay. This is how we have to solve for the energy if it is given a pulse. Okay. This is very important. It will be asking for 8-mark question in the examination. Okay. In the same way, here one more example, that is the trapezoidal pulse x of t is shown in figure is applied to a differentiator. This pulse is going to be applying for the differentiator, that is y of t is going to be taken d by dt of x of t. What they asked, find the resulting output y of t of the differentiator, then find the total energy of y of t. We have to find what is the resulting we will be getting after the signal is coming here. Differentiator is nothing but we are giving the input. It's like a system. The differentiator is the system. We are giving the input, that is x of t. Here a differentiator is there, that is act as a system, and you will be getting the output as y of t signal. A differentiator, what will be going for? Differentiator is going to differentiate our x of t signal and it will be producing the output, that is y of t signal. Okay, that's what we have to do here. First we have to find what is the resulting y of t of the differentiator. Then we have to find the what is the energy of the y of t. First we have to find what is the differentiator. Then we have to find the what is the energy we will be getting after differentiating the signal. What you have to do? First, if it is this question, if it is asked for 10 marks or else 8 marks, depends on the question paper. Here they didn't give for us what is x of t we will be getting. We are from the previous problem we got to know that what you have to do up to from this from solution up to where you will be getting x of t. Okay, up to this the same method you have to follow. The same thing you have to write as it is. Then we will be getting of our x of t, that is 5 minus t, 1 t plus 5 when it is with the different times and 0 for the otherwise. Up to this we have to solve. Then we have to go for the differentiating. We got our x of t from the previous what we done. We have to follow the same steps. Here I wrote direct values only. Okay, we have to solve for this. You'll be getting the points like this. Okay. Then what you have to do? This x of t is going to be undergoing for the differentiator. If it is differentiated, I will be getting a y of t. That's what here I wrote. Y of t is going to be taken dx of t divided by dt. That is going to be, if I differentiate with respect to t, that is 5 minus t, what will be getting? 5 is a constant, it will be 0. Minus t differentiating is going to be minus 1. 4 to 5 after differentiation you will be getting as minus 1. Then from minus 4 to plus 4, what is the amplitude is there? 1. What is the 1 differentiation? It will be 0 only. For that reason here I didn't return. That is minus 4 to plus 4, it will be 0 only. After differentiation it will be getting as 0 only. Then at the time minus 5 to minus 4, that is t plus 5. After differentiation, you will be getting as 1. Only t is there. T differentiation is going to be taken as 1. 5 differentiation is 0. So, for other values, including all the values, including of minus 4 to plus 4, it will be 0 only. That's what the last line. 0 otherwise. If I plot what is after differentiation of the output signal, y of t, what I will be getting? Like this, a pulse I will be getting, which is varying from minus 5 to minus 4 with the amplitude minus 5 to minus 4 with the amplitude as plus 1. Then for 4 to 5 it will be minus 1. 4 to 5 it will be minus 1. Next, use of the energy equation where it is varying from minus infinity to plus infinity x of t whole square into dt. Then the signal is varying with 2 points only, that is from minus 5 to minus 4, then 4 to 5. For that reason, it is limit is changing from minus 5 to minus 4. What is the amplitude here? 1 square. X of t is nothing but 1 square into dt plus integration 4 to 5. 4 to 5. It is of minus 1 square. X of t is nothing but minus 1 square. This is x of t minus 1 square into dt. Next, simple. Do the integration. One differentiation is integration is going to be t. Apply the limit. Then again here we will also get 1 t only. Minus 1 square means 1. After integration you will get as t. Apply the limit. Here if I apply, upper limit is of minus 4 plus minus of minus 5. You will get as plus 5 plus 5. Lower limit is 4. 5 minus 4. If you do the calculation, you will be getting as 2 joules. This is also important. This is also asked in the exam for 8 marks. Okay, this is how you have to solve the problem. Don't remember that you should not write directly these points. You have to do the apply the line equation, then solve further, then you get x of t, then differentiate x of t. You will be getting as the points and you will be getting as a graph like this, then apply the energy for this, then you will be getting the energy as 2 joules. This is one type of problem. Next is here we solve for the energy. Next we go with the solving for the power. Okay, here the problem it is given. What is the average power of the triangular wave shown in the figure? We have to find the power. Power is always a periodic signal. For that reason it is continuously varying. Okay, what is power equation? P is going to be taken as 1 by t integration minus t by 2 to plus t by 2 x square of t dt. First we have to find what is the t value. Observe here, what is our time period is going to be from the graph, from minus 1 to plus 1. One line is varying, right? Then from we have to consider for the one complete cycle, right? Positive to the positive to the positive, or else if it is starting, just remember at x of t at 0 point. Okay, it will be easy for to find out. One point to the another point, it should remain as it is. It is going to be one whole cycle, one complete cycle. Like in your sine wave, how will be going for one whole, right? One whole will be taking as this as t. This is I will be taking as t. Here also from negative edge to the negative edge, or else positive edge to the positive edge. Here, what is the time is going to be 0 to 0.2 seconds, right? Time is 0 to 0.2 seconds. From 0 to 0.2. Again from 0.2, it's the signal is changing. For that reason, your time is going to be taken as 0.2 seconds. Then substitute here 1 by 0.2. Where it is varying from 0 to, what we will be doing only at this point. If I calculate the power, and the same power is continuing further also for each of the signal, for further signal, because it's of a periodic signal. For that reason, for one pulse, one sample, or else one part of the signal, if I find the power, that power is remains same for the further part also. For that reason, okay, here 0 to 2. For that reason, limit is going to be taken from 0 to 0.2 x of t whole square into dt. Then again I am going to use here the line equation from this point. From 0 to 0.1, from 0 to 0.1, what is the line? It is like this, this one line. Okay, 0 to 1 is straight line, and again from minus 1, sorry, 0.1 to 0.2, one more line is there. So I can take the two line equations here from 0 to 0.1 and then from 0.1 to 0.2. For that reason it is divided 0 to 0.1 x of t whole square, then 0.1 to 0.2 x of t whole square into dt. Next, first I will find for this line what is the point I can take here. At the starting of the line it's going to be taken as 0 comma minus 1, right? Then here what is the point I will be getting here, 0.1 comma 1, because the amplitude here it is going to be taking 1. For that reason x-axis is 0.1, y-axis is 1. Here x-axis is 0 and y-axis here it is going to be minus 1. That's what I directly here I wrote the equation, that is x1 y1 x2 y2. At this line here it will be taken as 0 comma minus 1 and 0.1 comma 1. 0 comma minus 1, 0.1 comma 1. Next, at x2 y2 of this point, okay. Here what I will be getting here? Here we will be getting as 0.2 comma minus 1. Okay, that's what x1 y1 for the first line, that is from here to here it will be taken as 0 comma minus 1. In the second part, second line, okay, that here I can taken as 0.1 comma 1 and x2 y2 as 0.2 comma minus 1. The same thing here I wrote directly. Then you can use the equation, 2-point line equation. Substitute here I wrote the solution here, that is we will be getting as y2 minus y1, y2 is of 1 minus of minus 1. For the reason 1 plus 1 you will be getting, that is going to be equals to x of t, y minus y1 we have to take, y is nothing but our x of t. For that reason y1 is of minus 1 plus 1. So here you will be getting as x2 is of 0.1, x1 is 0. For that reason 0.1. x1 will be 0, will be getting as t. Like this you substitute, you will be getting, after solving you will be getting as x of t is equals to 20t minus 1. In the same way substitute for the second point also. You will be getting x of t as minus 20t plus 3. A simple calculation I hope you can do of this. Just go on here, just after this, just here 0.1 is there, here 20 is there. What I did, this 0.1 I can write as 1 by 10. If I multiply the numerator, denominator part, if I take to the numerator, it will be going for the 10. 2 into 10 is 20. Okay, same way you have to do here. Just you multiply here, you will be getting as x of t as 20t minus 1 and then minus 20t plus 3. Okay, small, everything is given, you just go through this. So you will be getting the results for x of t. Next what you have to do, just brief out those values what we got. X of t is going to be taken as, when it is 0 to 0.1 you will be getting as 20 into t minus 0.05. Here what I did, just I took that 20 as outside, or else you can write directly, no problem. Okay, it's your wish. You want to write directly, you can write, or else you can take 20 as outside also. Take a comma and you can write. Then here I wrote as, here also taken 20 as outside, 20 minus t. After taking 20 as outside, you will be getting as 0.15, where the signal is varying from 0.1 to 0.2. Next what you have to do, just substitute here. For each we got x of t values. You substitute here x of t values 0 to 0.5 and 0.1 to 0.2. My suggestions, no need of writing taking 20 as outside only. Directly you write 20t minus 1 and minus 20t plus 3 directly. That will be enough. Here I wrote directly. Okay, it will be simple for the calculation part. That's it. 20t minus 1 whole square, then minus 20t plus 3 whole square. Next, as usual, apply a minus b whole square. Here also a minus b, a plus b, or else you can write 3 minus 20b, 20t, then a minus b whole square you can apply. Just to apply here, after applying, take the integration of each factors. Okay, then apply the limit. You will be getting like this equations. Just go on doing of this. Lengthy, but it is easy, but don't skip each single point here. Single parameter, if you skipped, you will be getting the wrong result. For that reason, go on solving step by step. No hurry in the solving, okay? Because each question will be asking for directly 8 marks. For that reason, okay? Then go on solving this. You will be getting as 1 by 3 watts as the result. Okay, I hope you can do of these intermediate points. Just solve for this. This is how you have to solve for the power signal. Here we'll go for the next problem. Here they are given a structure like this, where it is half part is of a triangle, then again it's a different structure it's given. Okay, this is once it is asked in the 15th scheme, 10th scheme question paper. They asked like this pulse. Okay, we have to find. They didn't told find the relevant energy or power signal of the given sample they asked. First you have to find whether to which one we have to find. Okay, this is not a continuous time signal, right? Continuous, it's not varying, means it's of not a periodic signal. Then you can decide that it's of a non-periodic signal. If it is of non-periodic signal, what we have to find? We have to find the energy. Use the energy equation, minus infinity to plus infinity x of t whole square into dt. Then the signal is varying from 0 to 2, 0 to 2 x square x of t whole square into dt. Then wherever the signal is going for, what you have to do here? First you find which are the line equation I can get, the lines where I can get. Here from 0 to 0.5, one straight line is there. Yes. Then from 0.5 to 1.5. Observe here, 0.5 to 1.5, one more straight line is there. Then again this from, I can just with a dashed line, from 1.5 to 2, this is of a pulse, right? With the amplitude as -1 only. Observe, here is a straight line from 0.5 to 1.5, again one straight line is there. Then from 1.5 to 2, on the 1.5 to 2, this is a small pulse, direct pulse, a square pulse is there with the amplitude as -1. So if you solve for this by using of the line equation, you will be getting as x of t as from 0 to 0.5, you will be getting as to 2t. Apply the line equation, then you solve, you will be, then only you will be getting of the x of t equation. Okay, you have to solve. I didn't show those points here, you have to do that. Okay, then from 0.5 to 1.5, this is straight line, you will be getting as -2t plus 2. Okay, then at 1.5 to 2, here with the amplitude as -1 only. Then what you have to do with these limits, with time varying function, just apply for each x of t. Then 0 to 0.5, you will be getting as 2t square. Then 0.5 to 1.5, you will be getting as -2t plus 2, that the whole square. Then 1.5 to 2, it's of a pulse, so you will be getting as -1 whole square into dt. Then again same steps, you go on solving here. 2t square means 4t square. Here use your a minus b whole square equation. 4t square plus 4 minus 80 you will be getting. Here minus 1 square means 1 only. You'll be getting as t only. Then what you have to do? Integrate for each parameters what we done in the previous. Just go on and substitute here. You'll be getting as 1 joules. E is going to be getting as 1 joules. I did 2-point equation here. Just go through this. You'll be getting as x of t as these 2 points. Okay, this is it is asked in the examination. Different structures will be given. First you observe, are we getting a line equation, means a line, or else is there any pulse, or else is there any rectangle? Based on that you go on solving the problem. Okay, this is one more problem, it is asked in the examination. Okay, then another example. Here a rectangular pulse x of t is defined by x of t is going to be taken as, when it is varying from 0 to t, it is amplitude is a and 0 for other values, is applied to the integrator. This rectangular pulse is applying to the integrator, that is minus infinity to t x of tau d tau. What you have to find? Find the total energy of the output signal y of t. They given the equation. First we draw the line and the graph. Okay, here x of t is 0 to t, means from 0 to t with the amplitude as a only, x of t into dt. What they asked? First it is going to be integrated. Same thing what we done in the differentiation. Here it is going to be taking integration. That's it. So apply that. Use the equation of the integration, that is minus infinity to t x of tau d tau. What is the x of tau? Amplitude here it is given a. For that reason a into d tau. What is the time is going to change? 0 to t. Here it will be 0 to t only, because don't change the 0 to capital T. Okay, remember this. Here the integration is going to change from minus infinity to t, but we don't have any signal from minus infinity. For that reason 0 to t it's going to be varying. If I integrate, I will be getting as a into t. A is a constant value. For that reason, then use the energy equation, that is varying from minus infinity to plus infinity, y of t whole square into dt. What is our y of t? It's nothing but a into t. If I apply here, I will be getting as a square into t square. And what is the time is varying here? 0 to t, capital T. 0 to t, you write a square into t square. If you do the integration part, you will be getting as t cube divided by 3. Apply the limit here, you will be getting as a square into t cube divided by 3 joules. Okay, this question is asked 4 or 6 marks. In some question paper they asked for 4 marks. In some question paper they asked for 6 marks. Okay, till now we end the session for today's. Today only you solve all the problems. Okay, almost these problems only asked in the exam. But if it is asked different pulse, you should be able to do that problem. Okay, next we will go with solving for the discrete time signal. Okay, I will end the session today.